Hey guys, here's a little surprise. I'm making you guys a video. I know I got frustrated with trying to record in class. But we're going to be taking note 7-1, multiplication properties of exponents. Today's date's 2/13/2020, and this should be very familiar with you. So we got a lot of vocab going on. We're going to practice two different events that happen with powers and products, and then some practice, and we'll call it a day. So, monomial, let's start with that one. We've been using the idea of the word terms, and a monomial is a term, but let's define it. It's a number, a variable, or the product of a number and a variable. Okay, so here comes that word I mentioned, term. Oh, I should say it's not necessarily just one variable. It could be variable or variables. And then term can have positive integer exponents. So this term can have positive integer exponents. So let's just give you a couple of examples. We've got 2x, product of a number and a variable. 14a squared b squared c cubed. Oops, I think I blew it. I think my a just is a. Here, let's write that again. I don't know why I pushed myself forward with that one. ab squared c cubed. So notice we've got a coefficient and three variables, and two of them have exponents. Those are considered monomials. A 5 alone is a monomial. Y alone is a monomial. So what's not a monomial? Let me draw a picture of one. AB divided by C. That is not a monomial. In other words, if you have a variable in the denominator, it is not a monomial. All right, so then we have a constant. So again, you got to know the language. And the constant is a monomial. That is a real number. In other words, there's no variable attached to it. Okay? So let's start with our little friend here. 3 to the 4th power. And we're going to kind of describe some things that we're seeing here. So this guy overall together is called a power. Okay, that's one way to describe him. The 3 plays a role. Oops, wrong color. The 3 is called the base. And that's the number being repeatedly multiplied by itself. Repeatedly multiplied by itself. Okay? And then the 4 is called an exponent. And it tells how many times the base is multiplied by itself. Multiplied by itself. Okay, now hopefully you heard the words exponent, and in it you heard the word multiplied, and in the base you heard the word multiplied. So bottom line is, this is a multiplication problem. Now, as always with our new chapters, the beginning lessons should be repeated information, and then it's going to get a little bit gnarly down the line. So if I have 3 to the 4th power, let's do this, 3 to the 4th power, it is the same as saying 3 times 3 times 3 times 3, okay? So I'm going to go to the next screen. You should still be on your first page. You will not be on another page until you see me write the title again. I just want to have enough room to write. All right, so next page, we're going to talk about one of the 2 rules for exponents when it deals with multiplication. So a power is a multiplication problem, but this is now when we're multiplying powers together. So product of powers. So you're going to get something that looks like this. 3 to the 4th power times 3 to the 5th power. Okay? So what I'm going to do is write this out, and this would be the same thing as saying 3 times 3 times 3 times 3, that's 3 to the 4th. And then we're going to multiply that by 3 times 3 times 3 times 3 times 3, which would be 3 to the 5th. And if you added those all up, you would have 4, 5, 6, 7, 8, 9 threes being multiplied. Okay? So there's got to be a faster way than expanding this out and counting. I mean, come on, that's pretty elementary. I'd do that with my 6th graders, but I wouldn't do it with you guys. So there's got to be a rule that we can come up with. When I'm multiplying 2 powers and the bases are the same, is there a fast way to figure out what its exponent's going to be? And the answer is, yeah, there is. So here's what it is. When multiplying like bases, you're going to add the exponents. I'm sure you guys caught that if I took 4 plus 3, I would get 9. So, fast way of doing this, okay? So, in algebra, we like to give our rules with variables. So, if I have a to the mth power, and I want to multiply it by a to the nth power, notice the bases are the same. What I'm going to do is write the base once, and then add the exponents, okay? So let's talk about the next one, which is the power of a power. Okay, I don't know if you hear it, but my old lady cat Patches just came up to say hi, and she's purring. So if you heard that little noise, that's not me, that's her. Okay, and if you wouldn't mind moving, that would be nice. Thank you. So the power of a power is when I take something like this, where I take 3 to the 4th power, but now I want to raise it to a power. So let's kind of logic it out like we did the last one. So if I have 3 to the 4th power, and I want to square that, that means I'm going to take 3 to the 4th power, and I'm going to multiply it by itself twice. That's what that exponent means. Well, according to our last one, if I'm multiplying and the bases are the same, then I write the base once, and then I would add the exponents. And that would give me 3 to the 8th power. But again, like I said, surely there must be a faster way of solving this, and the answer is yes, there is. So, when raising a power to a power, raising a power to a power, we're going to multiply. Notice I'm yelling at you, trying to get this point across. We're going to multiply exponents. So when I've got a power to a power, so I have an exponent, a parentheses, an exponent, this is all about multiplication. Because think about it. When you have a number butted up to parentheses and another thing on the other side, that means to multiply those two. Okay, so what does that algebra look like? Well, this one's going to be slightly different. So I have a to the mth power, and I want to raise it to the nth power. Then that says take the base and multiply the exponents. Okay, now what happens if there are coefficients? How's that going to change what this process is? So let's talk about that. So when multiplying powers with coefficients, you're going to multiply the coefficients. So you're going to do whatever math the operation tells you to do with the coefficients, but add the exponents. Okay? That would be assuming with like bases, right? Or the exponents of like bases. Let's see, of. Okay? And then second piece, when raising a power, with coefficients, to a power, we're going to raise the coefficient to the power as well. Okay, so when raising a power with coefficients to a power, raise the coefficient to the power as well. So I'm going to go ahead and go to my third screen, which is actually my second page of my notes. So we're on the right side now, and we're going to do some practice problems, not a lot, and then we'll call it a day. Good thing for a short day, right? So directions say simplify. So I've only got 4 examples for us. So first problem, I have 6n cubed times 2n to the 7th. Okay, so what I'm going to do is I'm going to deal with the coefficients first. So I have a 6 times a 2. So according to the rules, it says you multiply them like you would in any other multiplication problem. Next, we're going to identify the like base. They both have an n. And then we're going to take the exponents from those like bases, and according to the rules, we are going to add those. So this is what my brain is doing as I'm thinking about this problem. Then I do the math, and my answer is going to be 12n to the 10th. So that colorful brain step is simply that, a brain step. You don't need to show it unless that's what you need to do to help yourself get through the process if you aren't quite as confident about this material. Okay, let's try another one. 3pt cubed times p cubed t to the 4th. Okay, so we've got a multiplication problem. I want to multiply the coefficients, but I do notice something is a little bit amiss. What I'm referring to is I don't see a coefficient on the second monomial, but yes, it's there. It's that infamous 1. So if you don't see a coefficient, remember it is 1. So now we're going to go ahead and we're going to multiply, only one of those. We're going to multiply the coefficients, so that's going to give me 3 times 1. I'm going to identify my base, and it turns out I have 2 different bases. So we're going to start with the p's. And I have p, and then I'm going to do the exponents. So we have p to the, oh yeah, look at that, first power plus the third power. Then we're going to find t's, and that's going to be third power plus the fourth power. Okay, so I'm going to just jot a note over to the side. P is the same thing as P to the first power. Okay, so keep that in mind. Just like P means the same thing as 1P. Okay? Two different things. All right, so let's do the math. I get 3 times 1 is 3. And then P, 1 plus 3 is 4. 3 plus 4 is 7. So I get 3P to the 4th, T to the 7th. Okay? All right, let's try one of those other guys. And we get 2 cubed that we want to square and then raise to the 4th power. Okay, so what I'm seeing is exponent, grouping symbol, exponent, grouping symbol, exponent. So anytime you have a number butted up or an exponent, any kind of number butted up to parentheses, it means to multiply. So we're now switching gears to the power of products, or the product of powers, no, power of a power, there we go. I'll get it eventually. So we're going to identify our base, which is pretty simple. It's just the 2, which is weird actually. I shouldn't say that's simple because the base is a number. That's a little different than what we had. And then we're going to take our powers and multiply them. So 3 times 2 times 4. So it's like I'd have 2 cubed times 2 cubed. And then I would repeat that doubled 2 cubes 4 times, a total of 4 times. And then we'd get them all together, added it all up, and we'd get the same answer if we just did the math like this. So I get 3 times 2 is 6, 6 times 4 is 24. So the answer works out to be 2 to the 24th power. All right, now I'm going to do a doozy on you, because you know, that's how we work. So we've got the monomial 3xy to the 4th that we're going to square, and then we're going to multiply that by the monomial negative 2y that we're going to square and then cube. Wow. Okay, so this problem is like 2, 3 problems put together. All right, let's tackle problem 1. So I'm going to do the first guy. Let's take that 3. Now 3, which by the way has an exponent of 1, we're going to raise it to the power. Because remember how we said that when raising a power with coefficients to a power, raise the coefficient to the power as well. So we're going to do 1 times 2. And then we're going to have x. And guess what? He also has an exponent of 1. When we don't see it, that's what it is. And we're going to raise him to the power of 2. So we're going to multiply by 2. And then we have y, and it has an exponent of 4. And we're going to raise it to the power of 2 by multiplying by 2. All right? So that's what he looks like. Let's look at the other guy. Okay. This one gets a little bit complicated, so I'm going to have to break him down a little bit. So we're going to take his coefficient, negative 2, and we are going to raise it to the second power. Okay? And then we're going to take the y, which has an, oh sorry, I got to change him back. Let's change him back to black. Back to black. And then we're going to take him and we're going to multiply his exponent, and we're going to raise him to the second power as well, so times 2. And that's where we're going to stop on this one, and then we're going to cube that. So this is the brain step, but guess what? The next step is mandatory. What did we get when we did the brain step? Well, first guy, 3 squared, x squared, y to the 8th, and then how about over here? we're going to get negative 2 times negative 2 is going to give me negative 2 squared. We could leave it like that. I guess we could do it that way. There's so many ways to solve it. Let's do it. Let's do it this way. You know what? Let's go crazy. Let's go ahead and distribute that, or raise to the third power at the same time. So cube everything right now. So we still have that negative 2 that we are squaring. But now we're going to multiply powers, and we're going to multiply by that third power that's over there. We're going to do the same thing to the y. And again, remember we've talked about this so many times. There's so many ways to do this math. And let's see what we get here. We're going to multiply by 2. We've already done that. And then we're going to multiply that by 3. Oh, this is crazy. Okay. So let's get some math. So 3 squared is 9, and we have the x squared, y to the 8th. Now this side we got to take care of some business. So negative 2 squared is negative 2 times negative 2, so that's going to give me 4, and now I've got 4 cubed. So 4 times 4 is 16, and 16 times 4 is 64. But actually, you know what? I lied. I jumped the gun. I was trying to do too much in my head. So let's just kind of baby step it, and we're going to get negative 2 to the 6th power, y to the 6th power. Okay, now we can think about that. So negative 2 to the 6th power is the same thing as negative 2 times negative 2 times negative 2 times negative 2 times negative 2. How many have I got? 1, 2, 3, 4, 5 times negative 2. So I have 6 negatives, which means my answer is going to be positive. And I've got 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4, 4 times 4 is 16, and 16 times 4 is going to give me the 64. So I get 64 y to the 6th. So now we've been doing all this power to a power business, but now what we end up with is a product, or a product of powers. Yeah, product of powers. So what we're going to do is take our coefficients. And we've got 9 times 64. And then we're going to take our exponents. And let's see, I've got 2 on the x, and that's it. I'm going to take my y. And let's see, oh, I got more on this one. So I've got 8 from the first guy and 6 from the second guy. That's another brain step. So my answer is, let's see, 64 times 9, we get 36, we get 54, and 3 is 57. Oh, wow, what a number. 576 x squared y to the 14th. Ooh, that's enjoyable. Now, of course, I took a long time, but the reason is some of you may not have done this or not familiar with it or forgot about it. So you got to do as many steps as it takes, but there's definitely mandatory steps and there's definitely brain steps, okay? All right, good luck with this, guys. Talk to you later. Bye.